So basically, last time we talked about hypothesis testing altogether. And we talked about, of course, the different steps. And we talked about, of course, the steps of hypothesis testing. We had two procedures. One of it was using a t-statistic. Another one was using a what? A p-value. And we talked about like when you're testing hypothesis using a t-statistic, of course, each hypothesis need to begin by doing what? By stating the alternative and also testing its what? Its null hypothesis. Then we said that also after you setting the hypothesis, you need to specify the distribution of an appropriate test statistic and determine its critical what? Its critical region. I would say that the critical region is basically the probability of rejecting the narrow hypothesis, which in this case would be like now, if you're using a test statistic, you need to look at the value. Like if you're using a Z test, you need to look at the corresponding value of Z at maybe a certain level of what? Of significance. Then the next step we talked about would be like now, you need to determine the value of the test statistic from the sample data. If it is either a sample data, if it is a population data, you need to be known which statistics you want to do what? To be using. Then you also later talked about that after you determine the test statistic, of course, you need to compare it with maybe the t-value from the table, or from the chi-square table, or from the normal table, for it to either reject or for it to do what? To take the narrow hypothesis. So we are saying that you check whether the value of the test statistic falls in the critical region accordingly and reject the narrow hypothesis or reserve not to reject it. Is that okay? We're saying that note that we do not accept the narrow hypothesis because of the what? We do not reject the narrow hypothesis because of the type 2 error or the probability of false acceptance, and it is not specified in a test of significance. So we don't always accept. Is that okay? Whether reject or fail to reject, but do not accept the what? The narrow hypothesis. Then we say that we have another test criteria for when you're doing hypothesis testing, which was the procedure for testing hypothesis using the p-value. Is that understood? And we said, of course, all the two procedures, both the test statistic and the p-value, all of them the same procedures, and also the conclusion which is made when you're using a test statistic is similar to when you're using a what? The p-value. Is that okay? That if you take the narrow hypothesis and a test statistic, also you have to reject it and narrow hypothesis when using a what? The p-value, because of them are the same. So I'm saying that under the p-value, we formulate the narrow hypothesis and also its alternative and specify the level of significance, maybe alpha 0.05, alpha 0.01, etc. Then we specify the test statistic. It can either be a t-test, it can either be a z-test, it can either be a chi-square, depending on which data you are dealing with. Then you also say that determine the value of the test statistic and the corresponding p-value from the sample data. Of course, you need to compute it. You need to compute the test value. You also need to compute its what? Its p-value. Then decide whether to reject or not to do what? To reject. But we are saying that not. In practice, we use whichever method is convenient, and this may depend on the sampling distribution of the test statistic and the availability of statistical tables or computer software and the nature of the problem. When we were discussing last time in class, we said that of course you have a Z table, a P table, or a chi-square what? Or a chi-square table. So we are saying that if you want to decide on which method to use, the best method to use depends on now which one is what? Readily available. Like if you're using maybe like STATA or a computer, you may decide to use a what? A computer software, because for it to automatically test for what? The p-value. But if you're computing it manually in class, it becomes better using what? Statistical tables. Is that understood? Hello? Okay, Atibun, please remove your video. So, of course, after this one, we need to look at the different procedures of how we test the hypothesis. So, we're going to first look at we have the parametric tests and also have the what? The non-parametric tests as ways of testing for what? For hypothesis. So, we begin with what? We begin with the parametric tests as our what? Our first example. So, we are saying that, of course, these are the most common ones. Like you look at they are saying that parametric tests a test used only when we assume a normal distribution. Because you know we have a test statistic, we have a Z normal, we have a chi-square test, we have F tests, most of them. So for you to use these certain types of tests, we need to assume that data is what normally distributed. Is that okay? Data has a mean of 0 and a variance of 1. And the most common examples which are used, we have a t-test, which can either be a pair match or an unpaired match, or it can be a one sample small test. Yes, Alan.
Master, you're breaking.
I'm breaking all my network, which is poor.
Yes, your network is breaking.
This Kampala also has no network. Okay. I'm saying we are looking at what? The parametric tests. And I'm saying that these ones are commonly used when we assume what? A normal distribution. Like the Z test, the T test, the ANOVA test, and also maybe what? A linear what? Regression for testing for these parameters of the linear regression, or maybe a Pearson's rank correlation. So when you're using these ones, you always assume what? That the data is normally distributed. So the thing is that parametric tests are those that make an assumption about the parameters of the population distribution from which the sample is drawn. And this is often the assumption that the population data are normally distributed. So for you to use any statistical test, which is either t-test or chi-square test or proportion t-test, the assumption which is always made is what? That the data set is normally distributed. And of course, we have the why these parametric tests are better than others. Like, why are they commonly used in analysis? One of it is that we are always very interested in a significance test alone. These things of saying maybe rejecting the null hypothesis or not rejecting it. No? Because we always focus on want to see, is this population maybe normally distributed or it's not? Or is it maybe that maybe this value affects the other value more than the other? So that's always what? Our aim. And also want to look at maybe the confidence intervals. That maybe we are sure that maybe the average performance of students in a class are between maybe 80 to 90. For you to do that, we need to use the parametric test, the t-test, which can help you to do what? Commit standard deviations, commit the levels of significance, and make that estimate of what? Of a confidence interval. And make the non-parametric test, as we shall be seeing when we come to the next class. Another importance as why people use parametric tests is that it is difficult to do flexible modeling with the non-parametric tests. For example, allowing for confounding factors using multiple regression. Confounding factors here, when I can try to explain for you what it means, is that you can be having like maybe two factors, like maybe you have education level, and maybe you have maybe sex and performance. And you want to maybe basically deal with and also maybe of course some like maybe family background. So if you are looking at non-parametric tests, handling such a complexity becomes very hard. But if you're looking at parametric tests, you can do maybe a t-test sample for no proportions. You're comparing maybe performance between males and also performance between what? Females. And you can easily allow for what? Maybe when maybe family background is people are poor or rich or moderate. So you can easily handle such complexity if you're using parametric tests. Then you are saying that another advantage is that parametric tests usually have more statistical power than their non-parametric equivalent. In other words, one is more likely to detect a significant difference when they truly what? Exist. I remember the last class we talked about type 1 and type 2 what? Type 2 errors. And so type 1 error is the probability of rejecting a null hypothesis, which is true. And also type 2 error is accepting a null hypothesis, which is false. So basically, for the non-parametric tests, they have a higher statistical power that if we were to reject the null hypothesis, we find that it basically was really right. For us to reject it. If it was to accept it, we need to find that it was really okay to accept it. Unlike the what? The non-parametric tests. Is that understood? Then of course, one of the examples we've been talking about is a what? Is a non-parametric what? But not parametric tests. We say that of course these parametric tests assume a normal distribution. So we are saying that we are going to begin with this one of what? Tests which are concerning with the mean, and maybe the sample size is too large or greater than what? 30. And this one will become what? A large one sample, t-test. If is n is less than 30, it becomes what? A small sample, t-test. And of course, remember we talked about that if you are dealing with such a solution, you need to set a hypothesis, you need to set the level of significance, you need to compare the test statistic and decide whether to reject, to either to reject it or not, or fail to do what? Reject it. So when you have like one sample, of course, our narrow hypothesis was maybe looking at maybe the average performance is 70. So you can either say that you can either have various alternatives. You might not be sure what is either less than 70 or greater than 70, or you might have maybe a decision that the average performance is less than 70, it was greater than what? 70. So you find that you have very many what? You have very many alternatives, either not equal to mean, less than the mean, or greater than what? The mean. So they are telling us that on the basis of a random sample, when the sample size is very large, and also it is coming from what? A normal distribution. We have different ways of what? Of looking for the test criteria or the critical what? Region, which helps us to either reject or not what? Fail to reject, which is either Z alpha over 2, Z alpha, or negative Z alpha. And we say that when you want to use the Z alpha over 2, that's when you have an alternative hypothesis, which is what? When you use less is great, when you're not sure. Mu is not equal to what? To mu naught. It can either be greater or less. So we find that there is a what? It's a two-tailed t-test. So we use this one as a what? As a critical region. But if our alternative is maybe the mu is less than mu naught, we need to use what? This one. Then if the mu is greater than mu naught, it is now greater. So we use z of alpha, which is in this case. And of course, when the sample size is too large, our test statistic becomes x bar, or the mean is equal to minus its hypothesized mean over the variance over root n. Is that okay? Are you understanding? Hello? Are you understanding?
I'm understanding nothing.
Mr. Yasin?
No, master.
Are you following?
Master.
Yes?
Yes.
All right, that's good.
Yes.
Master, no. Master, no, we are not understanding.
Jovi, you're not understanding.
Yes, master. I'm not even, our things have refused to open. Master.
You don't have data.
I have data. We are here and Erin, but have refused.
To do what? To log in?
So it has refused. We are trying, but
Okay, we shall repeat. Oh,
so we
I'm
are
recording a video. You have to send you the what? The video, and you follow. You try to follow. So we can now proceed.
The video.
So after stating the null hypothesis, also getting a critical region, you need to determine the what? The test statistic you're going to use. So since we're saying that the sample size is too large, we use a what? A Z test for normal, which is normally what? Distributed. And there we shall be having what? Some example. One of our example is saying that suppose that you have 100 high performance tires made by a certain what? Manufacturer on an average 21,819 miles with a standard deviation of 1,295 miles. Test another hypothesis that mu is equal to 22,000 miles against the alternative that mu is less than what? 22,000 at alpha of 0.05 level of what? Of significance. So if you look at such a question, you need to know, first of all, you need to know the sample. The sample is what? Is n is 100. This implies that we are going to use a what? A Z test. You need to look at the narrow hypothesis. You need to look at also the what? The alternative what? Alternative hypothesis. And also you need to look at the what? The level of significance, or alpha. So we said if you're dealing with this one, of course you need to test a narrow hypothesis, which would be like maybe H naught is equal to mu is equal to 222,000. With this alternative that H1 mu is less than 22,000. So which means if you want to determine the critical region for this point, you need to use the what? The Z alpha this Z alpha, because since it is facing what? A negative side. That's okay. Then of course, so you find that you also need to determine the what? The level of the when should you what? Reject the null hypothesis. And of course, we talked about that if you have Z alpha of 0.05, if you go to the standard normal table, this one is about 1.96. Is it true? Those are statistical tables. We shall try to find out basically.
Master,
So,
you mean the one?
yes. Hello.
I mean those ones on in the book.
Yes.
What are you saying?
I'm like the table you have given us in the books. Okay.
Okay. So basically, what you're going to do is that now I'm going to show you. I think most of you have your laptops there, right?
Yes.
Okay.
But not connected.
So now we're going to try to going to try this example in what? In our I gave you STATA software to most of you. Is that fine? So we are going to try it now. So what you're going to do is what? Mango, what's the problem? Mango? Mango has raised up his hand.
I'm not getting the software you're talking of.
What? Mango?
Software, like which software are you meaning?
You can type in the chat. You type in the chat. You type in the chat. You comment. You can type in the chat. Some say we're going to use what? We are going to use STATA. For our next example. Out there.
No.
Okay, so those who have opened their software, or those who installed it, we are going to look at. Of course, we shall come. Hope you can see my screen, right? So we shall come to what? To statistics. Then you come to hypothesis. Then you come to this t-test what? Calculator. No, we are z-test what? Calculator. All together. But are you following?
Not even.
Now we are behind.
Okay. So of course, remember I was not the what? The one sample. Why am I looking at Then also now we're going to look at the sample size. So we include our sample size. Yes. Alan. Then our sample many from
Yes, master. My question is,
Yes.
we in the question, is equal to 22,000. But they have told us to against only of the less than 2000.
less
We
than
use, we're supposed to use Z divide by,
divide by
because in the null hypothesis it says
because
equal.
in the null hypothesis it says equal.
That was my question.
That
Do you
was
use
my question. Do you use
alpha Z alpha over
alpha
or
Z alpha over
or give it a
Remember,
remember,
we said that, let me show you.
we said that, let me show you.
When you're testing this null hypothesis, you need to focus on what? On the alternative.
Excuse me, sir.
Altogether. And the alternative, look at this alternative, the thing is that suppose that you have 100 high performance tires made by a certain manufacturer on the other
100 high performance tires
then
made by a certain manufacturer
miles
on the other
with a standard deviation.
819 miles.
This is another hypothesis,
Yes.
and this
With
one.
the standard deviation. This analysis is an hypothesis, and this one.
So the alternative determines the what? The rate of significance, and also whether to divide by.
The alternative determines the what? The rate of significance, and also whether to divide by.
Look at this one,
Divided by
and look at the null hypothesis. Find that we need to take
look
on
at
what?
this one, and look at the null hypothesis. We need to take on
Since the alternative is what?
this. Z development. Since the alternative is what? This.
Is that understood?
yes.
Is that understood?
Okay.
Yes.
So we're saying that in STATA,
Okay.
let me repeat now in STATA,
So I said that in STATA, can you repeat? Now in STATA,
you come to
Like in
statistics,
the upper, the things to
you
log
go
in,
to summary,
how am I supposed
tables
you
and
come to
this.
statistics, you go to summary,
Then
tables
you go
and
to classical test for hypothesis.
to-
Then say that since our n is large,
just for hypothesis.
we're going to use the what?
There's
Ability.
our any our x right.
So
Going
come
to
to
use
the
the
what?
what? Ability.
The test calculator.
So count the what?
It is the one
This is
sample.
calculator.
The sample size was
It is the
100.
one sample.
You increase
The
to
sample size was 100. You increase to 100.
Sir,
yes.
Sir. Yes.
after summaries and tables,
After
where do you go?
summaries and tables, where do you go?
What are you saying?
What are you
I'm
saying?
like, after that procedure,
I'm
after
like,
summaries and
that
tables,
procedure after summaries and tables.
after where do you go?
After where
You can type in the chat. You type in the question. You type the question in the chat.
you can type the question, type the question in the chat.
And the sample something was what?
And the sample something was what?
2000.
2000.
Then the population was what? Its standard deviation was what?
Then the population was what? This standard deviation was what?
The standard deviation is
The standard deviation is
Excuse me, sir. How am I supposed to use the strata?
so 1295. Is that true? One, 295, right? And then the mean, we are hypothesizing which mean? And our hypothesized mean is what? Our hypothesized mean is 22. 1, 2, 3. Then here the sample mean is what? Is 21, 81, 9. Altogether. So when you press OK, you're supposed to do what to bring for your what? The computation of the output. Is that understood? Hello? So they're telling us that is what? It's one sample Z test with observations which is 100. This is its mean. This standard data, standard deviation, confidence interval, etc. And we're looking at that our null hypothesis that the mean is equal to what? The mean is equal to 22,000. That's our null. The alternative is that the mean is what? Is this equal less than what? 22,000. So now we are going to use this p value to either do what? To reject or not to do what? To reject. Is that okay? So if you look at this value, the value this is 0. What? 0.008118. And if you look at this value, it's greater than what? It's greater than the level of significance, which is 0.05. Is that okay? And we said when the p value
Yes.
is less than 0.005, what do we do?
You understand?
Yes? Hello? Are you there?
Yeah, there.
What do we say that when do we reject the null
So
hypothesis?
when do null hypothesis?
If it is greater than this.
When it's greater than?
If it is greater than this.
So if you look at
When
this
it's
one,
greater than?
Less.
it's
So if you look at this one,
this guy is greater than
Less.
what? 0.05.
it's
Right?
this is
So
greater than what? 0.05.
we have to check the null hypothesis using the what? The p-value.
So do
Okay.
the null hypothesis. What? The p-value.
When you look at this z value,
So
if you look at this
when you
value,
look at
it's
this
also less
z
than what?
value,
It's less than
you look
0.
at this value, it's
Now,
less than what?
1.6.
It's less than 0.
Z value for z at 0.001.
Value for z at 0.001.
We reject the null hypothesis. Is that understood?
We reject the null hypothesis. Is that understood?
Is that okay?
Is that okay?
Understood there? Because that when you get the null hypothesis,
Understood there?
the statistic,
Because that when you get a null hypothesis,
the
statistics
values are supposed to be the what? Are supposed to be the same.
the values are supposed to be the what?
Is that okay?
Are supposed. Is that okay?
Okay. So if that is done, we can now continue from our work. So we have used the z statistic
Okay.
because
So
the
that is done.
n was greater than what? Than 100. So now we are going now to go when the sample size is what? Is less than what? 30.
Because the what?
So when the sample size is less than 30, let me first increase this one. So when the sample size is less than 30, so shall use the one sample what? T-test. And of course, we shall have our normal null hypothesis by saying the null hypothesis. We also determine the region. All together. Then now our statistic becomes the what? A t-test. We use a what? A t-test. Is that okay? We use a t-test. And of course, we either reject on what? Depending on whether the computed value is whether the table value or its p-value is less than the what? It's the corresponding p-value of that what? That value. So of course, they have some example. They have some example, and you're looking at saying that the specifications of a certain kind of ribbon of mean breaking strength of 185 pounds, if 5 pieces randomly selected from different rolls have breaking strengths of 171.6, 191.8, 178.3, and 189.1. Test the null hypothesis of mu equal to 185 pounds against the alternative of mu equal to what? Less than 185 pounds at what? That level of significance. Is that understood? If you look at that, each sample size is what? Is very small. So we need to use a what? We need to use a t-test since this what? The n less than 30. All together. You can also say that we need to compute the standard deviation because we don't have it. Then you also need to compute the what? You need to compute the mean and also the standard deviation of that what? That sample size. And if you look at this alternative hypothesis, the mu is less than 185, implying that we shall look at what? The t value at this point. Is that okay? Show the t value at this point. So if you recall very well, we are going to try to, I think I sent some work. Let me see. We are going to try to see how can you enter this what? This information in a computer. Is that understood? Hello? Members? Are you there?
We are here.
We're going to try to enter what? This information in a computer that then we can be able to run the what? The test statistic of what? Of this information. So to do that one, To do this one, of course, I did for you some start. I'm going to go back to start again. And I want you to follow here. So what you're going to do is you're going to do what? We are going to come to this STATA. Remember, STATA has very many windows, as you can see. You come to this window down and type the word edit in small letters and press enter. Is that okay? But I'm recording even the video. After we share with the video, you can do what? You can do some following. So we are saying that
Yeah. That's why.
we are saying that we have five break ribbons with the breaking strength of where is my example? With my breaking strength of what? Of 1. So I come here, I want 171.6. Then the second is what? 191.8. The next is 178.3, right? The next is 189.1. Are those 5? Oh, I'm missing something. 1, 2, 3, 4. No, they're not 5. Did I miss something?
In the book, there are 4, not 5.
Okay, I use
The
the sample
book,
size
there
of
are
what?
only 4.
They are 4, right? So there are 4.
Yeah.
So now
Yes.
I'm done entering with what? Entering my work in what? In STATA. Is that okay? Okay. So basically now, this one shows my what? These are basically like my results which have so far entered. And this is what? Its variable name. Is that okay? So what I need to do is I need to look at maybe its mean and what? And standard deviation. Because for us to do the t-test, we need to get the what? You need to have the mean, right? The standard deviation, and also maybe it's what? It's sample size, and it's hypothesized what? Hypothesized mean. So to do that one, we're going to basically do it both manually and using the procedure of a computer. So if you do it manually, you need to first compute its mean. So if you look at its mean, you just say maybe sum. You just say sum, summarize this variable 1, and it gives you what? It's giving us the mean. The mean is what? The mean is 182. The mean is 182.7. That's the mean. And standard deviation is what? 94.22313. Are the what? As my standard deviation, we're going to be using. Is that okay? And also the t-test is the t is equal to the mean minus the precise mean over the standard deviation over root n. So to be able to do this one, you also repeat the what? The same procedure. You come to statistics, but are you following? Statistics, you go to tables, you go to cross-cortex for hypothesis, then you go to t-test what? T-test calculator. All together. And of course, we're dealing with one sample. The sample size, there are 4. There are 4 respondents. The sample mean when we computed was 182.7, and the standard deviation was what? 9.422.313. And the precise mean from our answers here, it is what? It's 85. It's a what? 85 as our hypothesized mean. So which is what? 180 what? 85. And you also look at the what? Our level of significance, which is all confidence interval, which is what? 95%, which is the same as 0.0 what? 05. And just say what? Okay. So when you say okay, this is a what? This is my output. This is my or what? My or output of that what? Of that question. We are saying that we have 4 observations with a mean of 182.7, and it's standard what? Standard deviation. And we have the H naught, or the null hypothesis, that the mean is what? 85, and the alternative is what? The mean is what? Less than what? Less than 180 what? 85. We have its p-value, and we also have its what? Its test value. So if you look at this one, the p-value is 0. What? 0.3294, and this value is greater than what? 0.5 altogether. So what do we do here? We fail to do what? To get the narrow hypothesis. Is that understood? Because the p-value is greater than what? The p-value of significance, which is 0.05. Is that okay? Then after, we are now going to basically do it manually. We're going to basically now use the command for the computer to see what would be the output if you have run it using what? The computer. And to be able to do that one, we just need to do what? You need to come to maybe to statistics. Then you come to summary tables and tests. You come to classical tests for hypothesis. You come to t-test, mean comparison tests. But if we're looking at what? I want to sample. Then you need to come with the variable name is what? It's var1. And the precise mean is what? 180 what? 185. And just say what?
The speed is much.
Are we together?
No. The speed.
So you cannot try to compare these two what? These
Master,
two
you are too
tables.
faster.
This table and also this what? This table. You get it? This saying that, of course, you have the same observations, the same mean was the same, even the variance was what? Was the same, even the final answer was what? They will be the same. Is that understood? So this is when you are doing it manually by entering the results, and this is when you just run it using what? The test for the what? For the computer. Why is it to reject or not to what? To reject that hypothesis. Is that okay? And remember that the p-value is 0.3294, which is greater than 0.05, and so we have to do what? To fail to reject our narrow hypothesis. That the mean is equal to what? 185. So we fail to reject it. Is that understood? And we shall also basically, when we meet in the class, we shall also see how to do what? Just using the what? These test values, since we don't have t tables right now. Is that okay? Okay, that's fine. I think you are trying to understand. Also, we have also the same what?
Only that day.
We have some what? Some other example. Some other example here. It is saying that to deal with the customer's complaint, the average amount of coffee powder in a coffee tin is less than what? They advertised 3 pounds. 20 tins were weighed, and they gave the following what? Results. So if the testing show that maybe you tested the narrow hypothesis that the claim or the complaint claim is true, that maybe each tin when they advertise it is less than what? 3 pounds. Is that okay? So our narrow hypothesis will be that maybe each tin is 3 pounds. Our alternative that each tin is less than what? 3 pounds. So we need to verify this what? Hypothesis. But if you look at this, the number of observations we have chosen, which are 20 tins, they are also less than what? Less than 30, implying that we are also going to use a what? I want to sample what? T-test. Is that okay? And also to do that one, I shared with you some Excel file. I don't know if you saw it. I shared with you some Excel file, which was called, let me see. I think it's this one. Small samples, example. Did you receive it on WhatsApp?
Yes. Yes.
So now what I'm going to show you here now, what I'm going to show you here is how do you do what? How do you import like work from Excel to STATA? Is that okay?
But the STATA is not.
Because now the variables here are what? These variables are very many. So like typing them would take us a lot of time. So that's why I did capture them in Excel so that we can be able to import them. So to do this one, I need to go to File. I go to File. I go to Import. But I have an Excel file, so I'm going to import what? An Excel file. I import an Excel file. It brings for me this customer browser there. You can see. Then I come to browse. Then I need to look for where you saved it. So those who put on the laptops, you need to be able to know where you put them. So basically, I'm on my laptop. It is in this part under Boostema, and in year 2, in non-parametric, and it is a small sample example too. Then I open it, and I think it's supposed to be loading. Yeah, it's the one. Then I say import first row as variable name. I click import first row as variable name. I say OK. So now so far brought what? My information. If I type edit, you'll be able to see the what? My results here. That coffee powder, the first one had 2.82, the next one had 3.01, the another one had 3.111, another one had 2.71, 2.92, etc. So one test that the now I put that this on average, these things are less than what? Less than 3, which is advertised. Of course, you know, people in advertising, they be like, this bottle is very nice. Oh, this thing is very nice. Yet the kilograms are not the same. That in like if you're buying like maize flour, like you find that very many sacks are not equal to 10 kilograms or 25 kilograms. They are always like reduced by like 2, others are more than 2 kilograms, etc. So want to verify this what? Claim or not what? Not hypothesis. So as we said, of course, we shall always have to first do what? We shall always have to first test the null hypothesis. We said the null hypothesis at the mean that maybe when advertising, a coffee is what? 3 pounds. We look at this alternative. We look at this level of significance. Then also look at what? How to compute it. So you're going to use what? I want to sample what? T-test to solve this what? Hypothesis. So if you're using now the computer, we shall just do the same criteria as we did. We shall go to statistics. We go to summary tables and tests. Then we come to classical test for hypothesis. Then you come to t-test, mean comparison test. But we are still using what? I want to sample. And the variable now is what? Coffee powder. And the percentage value of the mean is what? Is 3. And then also you do what? You run the output. Is that okay? So we are saying that we have a t-test for coffee powder that the percentage value is 3. We have 20 observations, and this is their mean here. This is the standard deviation, and then maybe the confidence interval. You have the t computed, which is here. You have the narrow hypothesis that the mean is equal to 3, and you have the return that the mean is less than 3, and this is what? Its p-value of 0.028. And if you look at this one, its p-value is less than 0.05. Is that okay? So which means that of course we shall be able to do what? Which means we shall be able to reject the null hypothesis since the p-value is less than 0.05. Is that understood? Okay, yeah. The video is being recorded, so you shall also go back and review and do some follow-up. Are you understanding?
Somehow.
Yes. Hi, how do I log in the app? If I told you that we have a license, so people are using STATA. I told you that we need to put a license. Modesta is supposed to teach you how to do it, or Baruku. Ask Baruku Edgemate to teach you. Okay, so that has been basically dealing with what? One sample t-test, both when it is normal and when it is what? It's very small. Using a t-test and what? And the z-test. Mango, you're raising up your hand. What's the problem? Mango? What's the problem?
Me, I'm not understanding.
Okay, let's remove it. So now we continue to the what? We continue to another test. So we are also looking at now tests concerning what? The difference between what? Between means. So we are saying that sometimes we are interested in testing the hypothesis concerning the difference between means of two populations. That maybe want to see maybe the number of students, maybe the average performance is more than that of what? That of males in a class. So those become two populations. You have a population of females and a population of what? Of males. So you're saying that if you give them a task, do men perform better than women?
Excuse me, sir.
Or do boys perform better than boys? So that one shall look at what? A t-test or to sample what? T-tests. So they're telling us that sometimes, of course, maybe there are variabilities in the performance, or you don't know it. So when you know it, we first shall find that you're going to use the z-test for two sample t-tests. And if you don't know the samples, the variance, the variability within the two samples, you shall find I'm going to use the what? A t-test now. So I saying that they are like let us suppose that we are dealing with independent random samples with N1 and N2. Those are two samples with sample size 1 and sample size N2 from two normal populations having means when mean 1, mean 2, and maybe their variances are known. So one test may be that on average, the performance is not the same. And if it is not the same, it will be what? It will be different by a certain what? A certain number or a certain amount. So I say that maybe the null hypothesis that the difference between maybe the performance of male minus the performance of females is equal to what? To D. D, that's the constant. Or how different are they? Can there be a negative or what? A positive. Against what? Against another alternative that these two differences might either be more, can either be a positive or a negative. Or you are very sure that one of them is what? Higher than the other, etc, etc. So when you're dealing with this one, we, of course, after you're testing the null hypothesis and also testing the critical region, you need to tell the what? The critical region for such what? Such values. When the hypothesis is that alternative is mu1 minus mu2 is not equal to maybe that difference, our critical region becomes what? Z for what? Over 2. If our alternative hypothesis that maybe mu1 is greater than mu2, we have either this one
What's wrong? Remove your video.
2025, 2026.
We can look for it.
Eh,
By all
into Gaba collectors. Yeah,
What's the
she's enjoying.
I've been talking to myself and you didn't even ask me. Class, have you understood that one? Hello? Have you understood?
Master.
Yes?
Master Neda.
Hello?
The next time we repeat this chapter, it's just a request. Maybe when we are sitting in a lecture room, we can pick it better.
Okay. Next time we shall do better. So basically, this has been a Z-test what? When you have two samples all together and you're doing it what? Like manually. Then when you try to proceed maybe with the work, when you try to proceed, we're going to look at maybe the Z-test. So we're going to look at what? Now when the sample size is what? Is very small and you also don't know the what? The variance. So you're saying that if we have two samples of N1 and N2 and their variances are very small, but you even don't know them. So the test we've been looking at using the Z-test does not what? Does not apply in this case. So we are saying that, however, for the independent random samples from two normal populations having the same unknown variance, the regular technique uses a test based on the what? Of the difference in means, but we use the what? Approved sample size or approved standard deviation. Is that okay? So when the two samples are of different sizes, this is how we shall compute the what? The approved sample size. Altogether, that when N1 is not equal to N2, this is how we shall compute the what? Approved sample size. And of course, like if you're trying to reject the null hypothesis somewhere using the t-test, this is how we shall compute this what? Level of significance or the critical what? Critical region for that case. And also, of course, maybe like when the sample size maybe when N1 is equal to N2, this is how we shall compute our what? Our approved what? Standard deviation for the two samples. Is that right? Have you tried to understand that? And then, of course, maybe we shall have some example there. They are telling us that in the comparison of two kinds of paint, a customer testing service finds that a 4-gallon can of one brand cover has an average of 546 square feet with a standard deviation of 31, whereas another 1-gallon can of another brand has an average of 492 square feet with a standard deviation of what? Of 26 feet. Assuming that these populations are normal and have an equal variance, so we shall basically use what? A t-test, but their sample sizes are, of course, are small. Altogether, they are 4 gallons, so their sample sizes are very small. So I'm saying a test and I pose that the difference between the means is equal to 0, or the other greater than 0 at what? 0.05 level of significance. So of course, to do the same thing, we should also do it in the STATA normally. So we have like our sample size 1, which is 4, and sample size 2, which is also equal to what? To 4. So implying that they have the same sample size, so we shall be able to use the what? We'll be able to use this formula for computing the what? We shall be able to use this formula for computing our approved what? Our approved variance. Altogether there. And also the sample size is very small. Then of course we shall have our standard deviations, which is 31 for group 1, and also some for what? 26 for group 2. And then we have the average means as 546 for group 1, and the mean as 4.92 for what? For another group. Then of course when you come to STATA, So when you come to STATA to do the same thing, you need to also go to statistics. You go to summary tables and tests. Then you go to classical test for hypothesis. Then now we're looking at what? A t-test calculator, but we want to, for what? 2 sample. So choose the what? A 2 sample. Then you put for sample size 1, which is 4. And sample size 2 is equal to what? Which is 4. Then you have what? The mean. The mean for one of them is what? Is 546 for sample 1.
No.
Then the mean for sample 2 is what? Is 492. Then standard deviation for it is what? One of it is 31 for group 1. Then another is what? 30 what? Is 26 for group 2. So we are looking at that. I think that when they have an equal what? Equal variances and an equal what? And unequal variances altogether. So we say that if if you look at our thing here, we are saying that they have a what? Equivariances. And if they have equivariances, we shall need to do what? We shall basically use the what? This formula. Altogether, this SP here. We have what? Equivariances. Is that understood? Okay. If that one is right, we have tried to understand there. So just come and leave this what? Because for us also these variances are what? Are equal. Then you just press what? Okay. And then you come and look at the what? The result. Is that understood? So I think that of course we have a two sample t-test with equal variances, and all of the two samples have 4 observations, and these are different means, and these are the what? They are standard deviations. And of course, maybe when you combine them, this is the total mean, and maybe the total difference, and of course the H0 or the narrow hypothesis is this one, and this alternative is that we are looking at the alternative that the difference what is less than 0, implying that we're looking at what? This one. And if you try to look at the conclusion of the p-value, we shall fail to do what? We shall fail to get the narrow hypothesis. You get? Since this one is what? Is greater than 0.0 what? 0.05. Is that okay? And I think are you tired? Hello?
For sure, master.
Yes.
You're not understanding?
Hey, master, wait us.
Okay.
For sure, the degree has lowered down.
What? You don't have network there?
We have.
Okay.
But it is very poor.
You start registering in the chat. You put your name and student number.
Which chat?
Master, which chat agree?
You just in the chat.
Master, which one?
You just
Okay.
you type your student number and the regular number in the chat.
Oh. That's good.
Also, others have to you register others. Others you register also.
Oh.
So basically, since I think you're tired and maybe you don't have network, we are going to stop from what? On this point, right? We are put sort on the what? Paid sample test, and we shall start from there next time when we meet next week. Is that okay? Is that understood? So you tell your friends to first register, then we can stop we can end the lecture from here.